All right, so 7.1 is called ratios and proportions, and it covers exactly that. A ratio, which is like a simplified fraction, and the proportions, which are two of them set equal to each other, where you cross multiply and solve. That's pretty much the entire concept. So if you can cross multiply and divide, you're good on the solving part, okay? And then there's just a couple of different ways to apply it. So we start with what's a ratio. A ratio is a comparison of two quantities by division. So one over the other, or 1 to the other with the word 2 between it, or A with the colon between it, B. So there's 3 ways to write the ratio of A to B, and those are them. A and B have to be expressed in the same unit and then written in simplest form. So if one is inches and one is feet, we convert them both to be the same thing. If one was minutes and one was seconds, we would convert them both to be the same thing. And then simplest form means you always reduce a fraction. So if I had something like 2/4, I'm always going to rewrite that as 1/2. So simplest form, again, always going to simplify your fractions, and then same unit, meaning that whatever one is, the other one has to be the same. Inches to inches, feet to feet, miles to miles, seconds to seconds, all that good stuff. All right, so this says a pygmy rattlesnake has an average length of 18 inches, while a western diamondback rattlesnake averages a length of 5 feet 6 inches. What's the ratio of the length of the pygmy rattlesnake to the length of the western diamondback? So the first thing is you want to pay attention to the order that this is given. First comes the pygmy, then comes the western diamondback. So when we write our ratio, we're going to write it that way. So the pygmy rattlesnake is 18 inches, right? So 18 inches would go over the length of the western diamondback, which is 5 feet 6 inches. But what did we say was true about the types of units for a ratio? They have to be the same first, right? Then we're going to simplify. So if the top is only in inches, then the bottom has to only be in inches, okay? So I need to convert 5 feet 6 inches into just inches.
66 inches.
Good. How'd you get there?
12 inches.
Yes.
1 foot.
Yes, which is
So
60.
12 times 5 inches.
Good. So there's 12 inches in a foot, right? So we do the feet times 12. This is what David's saying in English, right? So with the feet times 12, which is 5 times 12 is 60, and then add on to those 6 inches. So this is 18 inches to 66 inches. And then we said that those have to be reduced. So what's an easy number that's divisible into both of those?
6.
We could try 6, right? So this would be 3. And this would be 11. Anything else go into both? Nope. So my ratio is just 3 to 11. I don't need the inches because it needs to be in the same unit. Okay, it needs to be a reduced fraction, or it can be written as 3 to 11 this way. So either of these answers are okay. But we have to convert them so they're in the same units, and then we need to simplify them. Mind that you're always going to change the bigger one into the smaller one, right? So like feet and inches, I know inches is smaller, so I'm going to go from feet into inches. If it was minutes and seconds, I know I'm going to go from minutes, change it into seconds. So you're always going the smaller one. But yeah, before which I haven't even made yet, before your quiz, which will be next week, I will let you know all the conversions that I expect you to know. Yeah. All right, example 2 says the measures of two complementary angles are in the ratio of 1 to 3. What are the measures of the angles? There's a couple different ways to set this up, okay? But if I know, first of all, I need to know vocab. What does complementary mean? It adds up to 90. So these two angles, this first angle, this 1 times something plus 3 times something gives me 90, which means 1 times x plus 3 times x is going to give me 90. It's the same ratio, so it's the same variable. And then I solve it like it's an equation. So 1x plus 3x would be 4x equals 90. And then I would divide both sides by 4. 90 divided by 4. Good. And that's 5. Right?
Wait, why did you put that here?
Because I don't know what that ratio is. I know 1 plus 3 is not going to give me 90, right? So 1 times something plus 9 plus 3 times something has to add up to 90. And I have to figure out what that is. So that's just the x. To find the measures of the angles, which is what it's asking for, what am I going to do? Times it. Plug it back in. So 1 times x would be 1 times 22.5. That's the first angle. And then 3 times 22.5. And I do 22.5 times 3. 1 decimal place, so 67.5. Now what should happen when I add those two together? Should be 90, right? So if I check, now I know I'm right. 22.5 and 67.5 would be the two angles. Caesar.
How do you know that you have to multiply by 3?
Because the ratio is 1 to 3. Right? So that's what they gave you as the ratio, 1 to 3. So 1 times something plus 3 times something has to add up to 90. I just got to figure out what that something is. So I let that something be a variable. And then I solve for the variable, but then I have to multiply it back in. So you could also see the word supplementary there. What does supplementary mean? 180. So if it said that they added up to 180, I would do 1x plus 3x equals 180. Questions? Okay. An extended ratio is 3 things. So it's got A to B to C. So there's 3 things, or 3 or more actually. 3 or more total. So you could see 2 to 3 to 4. You could see X to Y to Z. Anything that's 2 or more would be called an extended ratio. So these you won't write as a fraction. Like you can't write 1 over 2 over 3. It wouldn't go like that. But you would see them in extended form like 1 to 2 to 3, just like that A to B to C is. You won't see these as a fraction. But you'll also see these in word problems like this. This says the lengths of the sides of a triangle are in the extended ratio of 2 to 4 to 5. The perimeter of the triangle is 77 inches. What's the length of the longest side? So now I'm talking about perimeter, right? How do I find the perimeter of a triangle? Add up the 3 sides. So it's 2 times something I don't know yet, plus 4 times something I don't know yet, plus 5 times something I don't know yet, equals 77 inches. So they have to be multiplied by the same number to give you a ratio, because that's how we would simplify it back. So you'll always take your ratio, multiply it times a variable. We're going to use x to be consistent, but it doesn't matter what variable you use. And then in this case, it's perimeter, so we add them all up and set it equal to 77. So now I'm going to combine my like terms. 2 plus 4 is 6, plus 5 is 11. 11x equals 77. Divide both sides by 11. And x is 7. But again, it's not asking for x, right? This one asks for what? The length of the longest side. So what am I going to multiply that 7 by? The 5, right? The biggest one. So 5 times 7 is 35. And it would be inches. If it had asked for all 3 side lengths, then I would have done 2 times 7, 4 times 7, and 5 times 7. But if it asks for a specific one, like this one, I only need 1. Listen. Because it asks for the length of the longest side. So the ratio 2 to 4 to 5 means the biggest is going to be the 5. The other thing you'll see with triangles, which I think there's one in the homework, is let's say that the ratio was 2 to 4 to 5, but it said the ratio of the angles in a triangle. So what do we know about the angles in a triangle? 180. So I would say 2x plus 4x plus 5x equals 180. So this time it said perimeter, and that's why we just added it up and set it equal to what they gave us. But if it had said the ratio of the angles in a triangle, I would do 2x plus 4x plus 5x equals 180. So it's all going to change depending on what it's giving you the information for. Okay, if we set two ratios equal to each other, it becomes what's called a proportion, okay? So an equation that states two ratios are equal is called a proportion. It can either be written as this, 2 to 3 equals 4 to 6, or as two fractions, 2 to 3, 2 over 3 equals 4 over 6. They're both correct. The numbers on the inside here, when you write it this way, are called means, and the numbers that are on the outside are called extremes. So if you think about like an extreme is something that's far out, and a mean is the middle, like an average, okay? The extremes are on the outside, the means are in the middle. So if I write it in colon form like that, then it will be the first and the last of the extremes, and the in between two are your means. If I write it as a fraction, the first number and the last number that you write are the extremes, and the second and the third that you write are the means. So that's just a vocab term you're going to see. Again, extremes on the outside, means on the inside. Cross product property is the same thing as cross multiplying. Okay, something you've been doing for a lot of years. If I have a proportion set up, then I can cross multiply. So if A over B equals C over D, then A times D equals C times B. In words, it's the product of the extremes equals the product of the means. You don't have to know those words, you just have to know that these two get multiplied and set equal to those two. And this is how you'll solve proportions. All right, so example 4 says, what's the solution of each proportion? A is 3 over 8 equals 5 over x. What am I going to do? Cross multiply. So 3 gets multiplied times x, and 8 gets multiplied by 5. The order of the 8 and the 5 and the 3 and the x don't matter. It could have been 5 times 8. But those two are the ones that have to go together. So then it becomes 3x equals, what is 8 times 5? 40. And then I'm going to divide by 3. So x equals 40 over 3, which is an answer because that's a simplified fraction. Or I could take 40, divide it by 3. I get 1, 3, 10. Just going to keep repeating. So this could be 13.3, or it could be 13, and then I could take that remainder, put it over my divisor, and 1/3. So any one of these three answers are good. Alyssa. You can leave it as 40 over 3 as long as it's reduced. So if it said like 40 over 8, you would want to divide them both by 4. But if it can't be simplified, you can leave it like that. Yeah, so any one of those three circled answers is good. Questions on that one? Okay, then goes B. Now I've got y plus 3 over 12 equals 5 over 6. So I'm going to cross multiply again. This time, 6 is going to get multiplied by y plus 3. So I'm going to keep it parentheses, and then I'm going to multiply those together. And then 5 times 12. So the 6 gets distributed. This would be 6y plus 18 equals 60. Subtract the 18. Y equals 42. 42 divided by 6 is 7. Good. So the good news is these are easy to check. If I take 7 and and I plug it back in here, I get 7 plus 3 over 12, which is 10 over 12. And what goes into both 10 and 12? 2. That becomes 5 over 6, which equals the other side. So proportions can be easily checked. Questions on that one?
Can I see the other part?
Mm-hmm. Okay, properties of proportion. So these are all the different ways you can write that same proportion, okay? If they're not 0, which, because you say they're not 0 because if I put them in the bottom and I divide by 0, it's undefined. That's why that's there, okay? If I start with this original proportion and I flip one side of it, so I get the reciprocal of the left side, then all I have to do is flip the right side and it still stays true. So if I had A over B equals C over D and I flip the A over B, now it becomes B over A, then I have to do the same thing the other side. It's still a true statement. Think about if I had 2 over 3 equals 4 over 6. First of all, is that true? Does 2 over 3 equal 4 over 6? Yes, right? If I reduce the 4 6, I get 2/3. Yes? You with me? Okay. Now if I flip the left side, I would get 3 over 2. Now I have to flip the right side. Equals 6 over 4. Still true. That's the first one, the reciprocals. The second one is by going left to right and left to right. So I go A over C equals B over D. So if I did that with this one, it would be 2 over 4 equals 3 over 6. Is that still true? Yeah, right? It's 1/2, 1/2. So they're different. It reduces different, but the left and the right side are still the same. And then the last one is the denominator addition. So I take the numerator, I add what's in the bottom or the denominator to it and keep it over the denominator on both sides. So this is this one, this is this one. And if I did that with the same ratio, it'd be 2 plus 3 over 3 would equal 4 plus 6 over 6. Which becomes 5 over 3, 10 over 6, which is also 5 over 3. So those are the 3 ways that you can change a proportion. What you cannot do is put A over D and C over B. We can't cross. We can't go cross. We go to cross to solve, right? But not to rewrite the same proportion. So you can flip them top to bottom. You can go left to right. You can add the bottom to it. But you cannot go across to rewrite it. You go across to solve it. Questions so far? All right, so how you see those is like this. It's going to give you an original ratio or proportion, and it's going to give you part of it. So part of it is changed. You got to figure out what was changed and then follow the pattern. So if I look at this original proportion, I have x over 10 equals y over 9. And A says x over y. So what happened there? We went left to right, right? So x over y would equal 10 over 9. Good. Now look at B. What happened?
Add the top and the bottom.
Good. Added the denominator to the top. So this becomes?
Y plus 9.
Good.
Did you get candies out?
No. And C?
You flip it.
Flip it. So 10 over x would equal? 9 over y. Easy stuff, right? That's it. Painless, right?